Hello. In part 2 of our problem solving section, we're going to look at a specific question to solve and practice some of the strategies we talked about in the previous video. So as you can see here, I have a photo of a landscaping project we put in our backyard several years ago. It consists of some lava rock, some sand, some pebbles, and some edging. And the question is, how much would it cost to build this? Now, at first glance, there's nothing dramatically difficult about that, but there is some geometry involved, and it's not a typical math problem in the sense that there isn't a straightforward algorithm to solve. We need to kind of work through some details before we can jump into this. So let's see which of these problem-solving strategies might be helpful. Well, the first thing might be to draw a diagram or a picture. And so let's go ahead and do that. It's not too hard in this case because the geometry of the situation gives us a natural picture. And so here's that landscaping project. Maybe there should be a little bit of a width here to this, but we'll ignore that for now. And then you can see there's an area for lava rock and then for the pebbles and sand as well. So that's drawing a picture. It also would be simpler if we split this problem into parts. All right, and notice there's several parts. There's, of course, we could solve for how much will it cost to get the lava rock, how much for the pebbles, how much for the sand, how much for the curved edging, which of course would be this piece and that piece, and then how much for the middle divider. So there's 5 parts of this problem, and we're going to focus for now on the lava rock. All right, so what else? Well, we can simplify the problem a little bit by assuming that this is a quarter circle. It's not entirely clear from the diagram that that's the right curve, but on the other hand, we have the permission to design this to make it simpler, and so we're going to assume a quarter circle inside a square. All right. What else? Well, we also need to know some more information. So for example, how big is the square? Well, I can tell you that it's about 13.75 feet in each dimension. Okay, and we also need to ask, what is the depth of the lava rock? And the lava rock depth will be 2 inches. Okay. Now, if for some reason we couldn't find out that information, we could do this problem in a per inch basis. But we know 2 inches is the answer. All right. What's next? Well, now we can translate our question into mathematical language. And so basically what we want to do then is we want to find the volume of the lava rock enclosed between a quarter circle and the boundary of a square. And I'm being more specific just for completeness sake here. Boundary of a square with side length 13.75 feet with depth of 2 inches. So this makes it a very clear problem that we can use geometry and so forth to solve. In fact, we can go ahead and do that now. We can see that if I wanted to know the area of this region, or the volume if I want to multiply by the depth, it's going to be basically the area of the entire square minus the area of this quarter circle. All right, so if you can visualize, this is a square, and then visualize that I'm subtracting out that quarter circle, then we can finish finish finding the volume. So the volume then is going to be the area of the square, 13.75 squared, minus pi times the radius, 13.75 squared, divided by 4 because it's a quarter circle. And then because we know it's 2 inches, I can do 2 inches divided by 12 because I want everything to be in cubic feet, right? This is square feet, this is square feet, this is inches, and this is inches per feet. And so that's going to work out to, if you work that out, about 6.76 cubic feet. We have one thing left to do, and that's to actually find the cost, because that was the original question. All right, so we found the volume, but what we really care about is the question, and that's where we have to research what is already known. So notice we've used several of our strategies here. And if we research it, we can find that maybe lava rock costs a little over $3 a bag. So lava rock is $3.12 per cubic foot bag. Now, of course, I can't buy a part of a bag. And so what's really important here is that 6.8 cubic feet works out to 7 bags. All right, and then I can multiply that to give me a total cost of $21.84, which is our final answer for this part of the problem. Now, if we wanted to give a more general rule that might be helpful for future reference, we could say that this works out to about $10 per inch depth. So if for some reason that was a more useful information because we were debating 1 inch or 3 inches, then we can quickly convert. Now, we still have 4 more parts of this problem to do, and that'll be for the exercises. So that's it for this section.